Hello, hello. Sanibonani. Can you hear me, guys? Hello? Ngiyangizwa. Anyone just reply? Okay, 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 okay. Hello, guys. Hello, guys.
We can hear you. Siyakuzwa sir.
All right, all right, all right. Just making sure that everyone can hear me. Okay, yes, 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 yes. Just giving people 2 minutes to log in. Yabona, naba abanye sebathi I can't join. Ngisho kudala imessage ukuthi abantu mabenze sure ukuthi barejistile ba-installile zonke lezo zinto. Okay, all right. Let's begin. Let's begin. Banye bazosithola ngendlela. So, right. Here's the case again. We have the paper that I've given you, both for Saturday and Sunday. Unfortunately, Laba Sunday, I couldn't see them because you were busy with maths. But then KM learners, we were able to at least push up until question 4, if I still remember correctly. So what I'm going to do now is I will just start this question paper from lay pants, and then ngizoloku ngikhuphuka nayo up until I get to the multiple choice questions. So basically, I will answer those multiple choice questions as the last questions. So yeah, the class might take about maybe more than 1 hour, 30 minutes, maybe 2 hours, depend depending on the concepts that I would need to explain. But then anyone is free to go if maybe to whatever concept that you wanted to understand. So right ngayo, especially for the ones whereby ngizoba ngiwaphinda futhi lawa for other learners here. But if you want to stick around and find the understanding futhi, you can stick around, right? So I don't know exactly when I will stop the class, but then kuzobonakala khona with my pace. So okay, what I want you to do there is be comfortable wherever you are, and then thole incwadi yakho, thole calculator yakho, and then work with me as I tackle these questions. So don't just listen to me, but now try to approach some questions, try to engage on some of the questions there so that you don't just consume, but then you also get to see ukuthi kukuphi lapho ungenza ama-mistake khona and also correct them. Okay, so I'm going to start from question 10, which is our electricity, which I know it might be a problem to a lot of people. So it's good ukuthi sivele siqale ngayo siyibekele esayidini. Okay, so first thing that we have lapho is to state Ohm's law, right? So it's the definition. What is Ohm's law? The definition goes like this. We say Ohm's law is what? The potential difference. It states that, so Ohm's law, we can just write it here. So Ohm's law states that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. So yes, there goes our definition, and then 2 marks wakho. So the potential difference across the conductor is directly proportional to the current in the conductor at constant temperature. So please note it down. That's your definition for Ohm's law. Ohm's law states that the potential difference across a conductor is directly proportional to the current in the conductor at constant temperature. Okay. And then, but what does the gradient of the graph represent? I want you to understand one thing about this, right? Ama-graph wakho lawa, they can be drawn in 2 different ways, if you notice. This graph can be drawn as what? As a current versus, so the way siyibone ngakhona lana, this is current versus what? Versus potential difference, or current versus voltage, right? So current versus voltage. In a current versus voltage, remember when you read the graph, you say the dependent variable versus the independent variable. So it's current versus potential difference. Now in a current versus potential difference, this is what you need to note. You need to note with the gradient of this graph. So let's note the gradient of this graph represents what? Represents the inverse of resistance. The inverse of the resistance. Why does this one represents the inverse of the resistance? Remember, a gradient MSA calculator, we normally say is the change in y values over the x values. But then here, if you can check here, our gradient will be indicated as what? Current over voltage, which in normal form, we know with our formula is R is equals to V over I. So the minute it becomes I over V, this is similar to you having 1 over R, or R to the exponent of -1, which R to the exponent of -1 is the same as 1 over R. So once you have I over V, we say that the gradient of the graph represents what? The inverse of the resistance. The gradient of the graph represents the inverse of the resistance. Once it's about a current versus potential difference. But if, however, we have ubani, potential difference versus current. So note ukuthi sometimes the current izotholakala la phansi, and then the potential difference itholakale le y-axis, right? There is no one way of drawing these graphs. Kuswa ngokuthi bona bakupheni. Now, if you find a potential versus current graph, potential difference versus current, then it means the gradient of this graph, represents the resistance, you see. So ungaclaim ukuthi I know potential difference kumele abela current abela bangayishintsha mabayishintsha abafaka current labafaka potential difference here, it means now you are dealing with the what, with the inverse of resistance. So here, as we can see, if we wanted to calculate our gradient, we would simply say it's what is the potential difference over the current. Change in what? In Y values, which represents the potential difference, and change in what? In the X values, which represents the current, which if we can look at this simply goes the same way as the formula to resistance. It's a V over I. So hence here we say if you have a graph SO potential difference versus current, it simply represents the resistance exactly as it is. But if you have a current versus potential difference, then it represents I over V, which is the what? The inverse of the resistance. That's what's important to note. By our time, my question now whereby you have to reason with the graph. There are two questions also electric circuits. It's one whereby you'll be given your electric circuits and you need to work out using formulas and all the knowledge that you know about series and parallel resistance. And then there is the other one, which is normally in question 10, whereby Felix Omele was interpret a graph. So you must be prepared for both those questions. So, okay, this is it. This is it. Please note it down. We have that. If you have a potential versus current, note that the gradient of the graph represents resistance. But if you have current versus potential difference, the gradient represents the inverse of the resistance. So yes, the lesson is being recorded, by the way. So you will have all the time to go through this notes. And then I made this class to be on Wednesday so that you have all the time to go through the notes, even Naxas. So just quickly note some of the few things there. If you miss them out, just ungathatha a screenshot lapho fast, just so that we can be able to cover more things. Okay. So I believe people have noted down. Then, so because we are given current versus potential difference, we'll say the gradient of the graph represents the inverse of the resistance. The inverse of the resistance. Now, 10.3, it says, without any calculations, state which resistor X or Y has the greater resistance. Now, in a case like this, how will you be able to determine which one is the greater resistance, which one is a smaller resistance? It is based on what? Here, because you understand what it represents the inverse. Normally, if this was a potential difference versus current, we would be looking for the one that is steeper, right? We would be looking for the one that has a greater gradient. But then in this case, you need to know to this represents the inverse of resistance. So if it represents the inverse of resistance, another way must now change, right? If it represents the inverse of the resistance, it means that now the one with the greater resistance would be the one with the what? With a smaller gradient. The one with a smoother gradient. So if we look at these two lines, we can see that normally we would reason and say OX has to be the one with the greater gradient. But then here, the greater in an inverse situation, it means the greater the gradient. So this works with what? This works with the graph whereby you have OR to the exponent of -1 representing the gradient. So it means the greater the gradient, because now say we inverse, the greater the gradient, the smaller the resistance. So how do you see a greater gradient? Obviously, you see it by how steep the line is. So this is more steep and this is less steep. And then the greater the gradient, the smaller the resistance. But the smaller the gradient, meaning if it is less steep, the smaller the gradient, the greater the resistance. the greater the resistance. So in a case whereby we want to determine between X or Y, which one is the greater resistance, it would have to be the one with a smooth gradient. It has to be the one with a smooth gradient. This is true because we are working with an inverse. But if we are working with the original, which normally if we are given a current, if we are given a graph yellow, a resistance like this, normally we have current down here. This is what we are normally used to. We have current being here and potential difference being here. So let me say PT, potential difference. Normally, in a case like this, whereby this is no longer representing the inverse of the resistance, it's just representing the resistance as it is. It means if I had the same graphs here, X and Y. So let me say X is this, and then Y is that. In a case like this, I would just say the greater the gradient, the greater the resistance. In a case like this, mangabe being no potential difference, ngaba no current la. And then I would say the smaller the gradient, the smaller the resistance. But what makes me say this now, it's because I'm dealing with the graph a representer inverse a resistance. So I want you to understand that and be careful of such things in the exam. So electric circuits questions can be a little bit tricky if you don't understand those concepts. So understand the first thing that you need to check there when you're dealing with those questions. Are you given a potential difference versus current, or are you given a current versus potential difference? So in the case here with 10.3, our answer would have to be what? Y. And then reason, it's because the inverse of the gradient of graph Y is greater, right? So we say because the gradient is small. Gradient is small, which represents a what? Which represents a greater resistance. According to this, according to the fact that we have what? The gradient is being represented by the inverse of the resistance. But if the gradient was being represented by the resistance straight, then it would be the opposite. So I hope it makes sense. I hope it makes sense. So yes, take time to note that. Note fast. Then 10.4 is now that one calculation question. Efuna sebenzise gradient, right? So in questions like this, you have to be, the calculation that you would have to expect is the one whereby you must use the gradient to calculate the resistance. Because throughout this question, what we are actually learning from this question here is that E gradient yakho will either represent the resistance or the inverse of the resistance, based on whether you are given current versus potential difference or potential difference versus current. So that's what they are always testing in this kind of questions. So, okay. Then how do I use this? How do I use the graph to determine the resistance of resistor X? I would have to say, to calculate my gradient, I obviously need to pick my points. So this is resistor X here. So I can go with, we can decide to go with 2 points that will be clear enough on the graph, right? So we only just need 2 points that will be clear. Any 2 points. I can go with 4 and 0.2. I can go with 8 and 0.4, right? Another one can decide to go with 10 and 0.5 nalo 0 lo. So any 2 points that make sense there, right? Any 2 points that you can actually see. Remember, these are all collinear points. So if you pick any other point, it's supposed to give you that. Even if you go with 6 and 0.3 nale, it's supposed to give you that. So we can say this is 4 is to 0.2, and I'm picking 8 is to 0.4. So you can do it with any. It's not that you have to pick those points. Any 2 points, you know how to calculate your gradient from maths. So this is y2 minus y1 over x2 minus x1. And then we're going to have what? So if I'm taking this one as the upper ones, I'm going to say 0.4. So I'm going to say this is x1, y1, x2, y2. So this is going to be 0.4 minus 0.2 divided by what? 8 minus 4, right? Then when you punch it into your calculator, your gradient will be what? 0.05. But remember, you are supposed to determine the resistance of X. You will remember that I said your gradient M represents what? 1 over R, or represents R to the exponent of -1. It represents your gradient, according to 10.2, represents the inverse of resistance, meaning in this case, your gradient is not equal to the resistance. So you would still need to do what? You will still need to say, but I understand that my gradient is equals to 1 over R. So if I want to calculate the resistance, I need to take this 0.05, put it here, and then say 1 over what? R. Then I just cross multiply this, right? So you know, skill set to semete. When we do this, we just swap the positions. So we'll just say our resistance now will be 1 over 0.05. So in a question whereby we had potential difference here and current, we were just supposed to say whatever that we get for gradient is our resistance. But if we have current versus potential difference, we need to remember the gradient is not really representing the resistance at this point. It's representing the inverse. So in order to find the resistance, we need to say 1 over that gradient that we got. So it's 1 divided by 0.05. Then we find that our resistance is supposed to be what? 20. So resistance is 20 ohms. Then we are no 4 marks wako. So you can even try when with other values and see if it's gonna still give you that 0.05. So that is it. So understand this, because this was representing the inverse. After calculating the gradient, we had to say the gradient is equal to the inverse of the resistance. And therefore, where there is M, we substitute back that value there, and then we just cross multiply, swap these ones in order to be able to calculate the resistance. Then we find that our resistance all in all is what? 20 ohms. Then inshallah, nothing crazy from that one. Nothing crazy. You have your 9 marks from your electric circuits. Then yeah, this is not the long form electric circuits. Obviously, question 9 is the one that holds a lot of marks. So your electric circuit is supposed to give you something like 30 marks in the exam. So you need to really make sure that you have it in the bag. It's going to give you something like 30 marks. So this is 9 marks. The one lay phezulu up is 21 marks. So I believe that you have the paper with you. I gave you the papers. So you can even be looking at the paper there. So 21 plus this 9, 30 marks wonke lobo electricity. So you know that you can't afford to lose it. Okay, then this is what we have. So a little revision yana on that before we can start. These are the things that you need to know under electric circuits. Obviously, this is about knowing the difference between a series and a parallel, right? Now, we know with a series circuit, the characteristic is that with a series, it is what? One pathway for current to flow. One pathway for current to flow. This one has what? Multiple pathways for current to flow. Right? And then we have to differentiate between a series and a parallel connection circuit based on three things: the current, the resistance, and the potential difference. So starting with the current, we know the current in a series, current is the same throughout. Current is the same throughout. But then with parallel, we say current is divided amongst the resistors. Which is why you will find with a parallel is sometimes called what? Current divider. So a parallel circuit is also known as a current divider. A series circuit is known as what? Voltage divider or potential difference divider. Remember, potential difference and voltage is one and the same thing. So current is the same throughout. Current is divided amongst the resistors. So that's the difference between a series and a parallel in terms of their current. And then isibuye, what is the difference in terms of their voltage? In terms of their voltage or their potential difference, so I'm trying to show you what in day one. So here we say voltage is divided amongst the resistors. Is divided amongst the resistors. And then here, voltage is the same throughout. Is the same throughout. Right? So voltage is divided amongst the resistors, and then voltage is the same throughout in a parallel. Right? So you see vice versa. This one is called voltage divider because it divides the voltage but keeps the current the same. This one is called current divider because it divides current but keeps voltage the same. And then the last part is their difference in terms of what? Of resistance. This is what we are investigating with my electric circuits. Current, voltage, and resistance. R is equals to V over I. Those are the three quantities. And then here we say resistance increases with an increase in the number of resistors. With an increase in the number of resistors. So the more resistors you keep on adding with series, you will find that your total resistance will increase. Why? Because the formula that you use is RS is R1 plus R2 plus R3. Depending on how many resistors you have, you're going to keep on adding them. So that will increase the sum. But then here, the more you add resistors, so resistance decreases. Resistance here decreases with an increase in the number of resistors. In the number of resistors. The reason why that happens here is because of the diminishing formula that you use. It's 1 over Rp is equals to 1 over R1 plus 1 over R2, and then depending on how many resistors are connected in parallel. So the more you put into this formula, the total resistance decreases because of how you calculate that. You calculate that as an inverse. So the more you're going to keep on adding, that means you expect a smaller answer, right? So, okay, these are what you need to know. So, ama-notes lawa lana, this is the rules that actually guide you having to answer those questions as well. So, know them and then apply. So series is a voltage divider, one pathway for current to flow, parallel current divider, multiple pathways for current to flow. How are they different in terms of their current? In a series, current is the same throughout. In a parallel, current is divided amongst the resistors. Then when it comes to voltage or potential difference, we say voltage is divided amongst the resistors, and then voltage is the same throughout. And then when it comes to the resistance now, we say resistance increases with an increase in the number of resistors because you apply the formula R1 plus R2 plus R3. Then resistance decreases with an increase in the number of resistors because of the formula that you apply there. So giving you time to quickly note there. Okay, must note any. And then, okay, are we done? Are we done? Are we done? Are we done? Okay, all right. Okay, nice one. Then let's start now. Define the term EMF of a battery. Define the term EMF of a battery. So anything that you need me to clarify, please uyenze lapho ku-chat. So as I'm doing here, I'm also reading whatever comments are on the chat. Okay, so for 9.1, define the term EMF of a battery. What are we going to say? What is the definition for EMF? So EMF, we define it as this. EMF is the maximum energy per coulomb of charge. So this is a very important thing, right? So your definition must have this weight. The maximum energy per coulomb of charge supplied by the battery. Supplied by the battery. Now, To help you understand EMF which is sevenza kanjani, when you go and buy a battery that says 12 volts, right? So that's your battery there, 12 volts. This is the maximum that the battery can supply. But then remember, your EMF is actually broken down to what? So EMF is broken down to V external and V internal. The internal voltage and the external voltage and the internal voltage. The V external is the one that flows through the circuit. This is the one that flows through the circuit. This is the voltage that flows through the circuit, that powers the circuit. But the V internally now is the one that remains inside the battery. So this one actually heats up the battery. The purpose of the V internal is to heat up the battery. So when you go to the store and buy a 12-volt battery, you can't say you want to operate something that is 12 volts and you go and buy a 12-volt battery. It will not work. So if you buy a 12-volt battery, then you're expecting that your V externally might be somewhere between what? 10 volts or even 9 volts. And then what happens to the other 2 volts? That's the internal voltage that is taken by the battery. Remember, in order for the battery to start functioning, it also needs to heat up. That is the V internal now. So that means what will be operating in the circuit is the external voltage, not the whole EMF. So the EMF is the total that the battery can supply, but then it doesn't supply all of its potential to the external. It only supplies a part of it, and then the other is taken by the internal resistance of the battery. So the battery itself has internal resistance, so which is what we are seeing here. So this smallanyana battery that is 0.6 ohms here, this smallanyana resistance here, it's not part of the external resistance that is here. It's inside the battery. So the dash line here indicate the battery, and then the battery itself has internal resistance, as they're saying here. So the battery used in the circuit below has an EMF of 12 volts and an internal resistance of 0.6 ohms, right? Then define EMF of a battery in watts. That's what we did there. The maximum energy per coulomb of charge supplied by the battery. Then you have 2 marks. So take note, Leo definition will always be there. So you need to know it. EMF and also Ohm's law. Those are the 2 definitions you don't have to miss when it comes to electric circuits. Then calculate the current that flows through the 3 ohm resistor. 7 marks. Now you don't panic, because we know a 7-mark question does not indicate the difficulty of the question. It's just simply telling us that there is a process that we need to take into answering those questions. Number 1, it's understanding that current flows where? From the positive terminal to the negative terminal. Now we know that if we are given our cell like this, the positive terminal is always indicated by the longer line, and the shorter one represents the negative terminal. So if we are to show the direction of the current here, it means current will flow from this direction. This is the positive terminal, this is the negative, meaning current will flow like this. Now the minute there is a junction, we say that the current enters the what? The parallel combination. This is how you do it. Where there is a junction, you start to change the color. So this is the color scheme method that helps you to actually understand circuits. Where there is a junction, now you'll start to change the color. This indicates that the current is split. Remember, in a parallel, we say current divides. Now, the current splits, and some of the current goes that way, and some of the current goes this way. Now, where you see the same color, it means the current is the same. So with the 15 ohm resistor here and the 9 ohm resistor, they have the same current, green current. Now the 8 ohm resistor is the only one with the red current. But if there is a junction here that divides the green and the red, there must also be where the junction ends, which means when the junction ends, the same color continues now. The same initial color continues, which was blue. So meaning where you see the blue, that's where it is connected in what? In series. Because what do we know? The series circuit always takes the whole total current. So the total current is equal to the current in the series. But when it comes to the ones in parallel, you have to actually add those currents so that they add up to the total current. So why? Because this blue current here divides to green and red. So when you add up the green and the red, it gives you the blue, which is equals to the one in the series. So that's the first point that you need to note. Now, another thing that you have to note is a situation like this. Whenever you have a situation like this is what we call series parallel connection. What is series parallel connection? Is a connection whereby resistors are in series, but then they're within a what? A parallel branch. Resistors are in series, but then they're within a parallel branch. In a case like that, I want you to note this properly. In a case like that, you always have to take these two resistors as one big resistor. You combine them. So at the end of the day, what you are seeing is this. What you'll be seeing is this. Is you will have to say 15 plus 9. You take it as one big resistor now. So you ignore the part that they're actually in different places. Because they share the same current, it means they can be taken as one big resistor, which is 24 ohms. If you add 15 and 9. But then that 8 ohm, it doesn't share the same current with those resistors. So we simply going to leave it like that. So at the end of the day, it means we actually have two resistors that are connected in parallel because these ones are actually taken as one big resistor. So you have the 8 ohm and the whole 24 ohm that are connected in parallel. So I want you to note that, very important. And then this is 3 ohm. Right, so this is what you are seeing. Don't mind this one. This one is for the battery, right? When we are dealing with the external resistance, this is what we want to see. Right, so that means we have these ones connected in parallel and only that one connected in what? In series. So what do we want to calculate? We want to calculate the current, but we do understand that in order for us to calculate the current, according to this, EMF, the formula for EMF goes as I, R plus small r, where the R here is the what? So let me explain this formula. So EMF is equals to I, R plus R. The E here is for EMF, of course, in volts. R, big R, is for the external resistance. Now, there is a reason why I call it external and not total. The total resistance in this case is your EMF. So this is the resistance that flows in the what? In the circuit. Then your small r is your internal resistance, which is that 0.6 that you saw there. And then obviously your I is your current, total current, by the way, in amperes. So this in ohms and that in ohms, right? So basically, you do understand that if you want the current, we do have the EMF already, it's 12 volts. We have the internal resistance is 0.6. So you know why is it 7 marks? Because we still need to calculate the what? The external resistance. So you must be able to select a formula and be able to understand why are you given so many marks, right? So it's because the first thing that we need to crack there is calculating the resistance. And as you can see the process comes with understanding this. Right. A lot of learners here will be confused and they will do 1/8 plus 1/15 plus 1/9 and they will be wrong. Because that's not how we do it. There are 3 resistors in parallel, we can see that, but then in actual fact there are 2 because these ones are taken as one. Remember, these two are actually in series to each other. So now we need to combine them so that they can be in parallel to that 8 ohm resistor. Now you go back to your past exam papers, you will see that trend. Okay, so step number 1, what do we do? From the formula, we can see that, we actually need to calculate the R external. So let's start with the resistors in parallel, RP, parallel resistors. Now, you can either do the 1 over RP or you do the sum, the product over sum formula. It's up to you. 1 over R1 plus 1 over R2, which will give us what? 1 over 8 plus 1 over what? Combine this, so it's 1 over 24. Then you're going to say 1 over RP. Now you take your calculator, 1 over 8 plus 1 over 24. This gives you what? 1 over 6. But you need to remember you are not looking for 1 over RP. You are looking for RP. So therefore you do what? You swap these ones. Make denominator, numerator, numerator, make it denominator. Or simply you can just do like this. What you do on the left, you also do on the right. This is equivalent to just swapping these ones. Therefore your RP becomes what? 6 ohms. So you see with the resistors in parallel, you don't just add them and say 8 plus 24, or you just say 8 plus 15 plus 9. That's not how we do it. If resistors are in parallel, the formula that we use is this one. Note that. The formula that we use is this one. Or, if you prefer this one, it's based on whatever lo ifundile esikolweni. If you prefer, RP is equals to R1 multiplied by R2 over R1 plus R2. Still, the same thing has to apply. It's 8 multiplied by what? Not multiplied by 9, not multiplied by 15, but multiplied by the whole of 24. And then over what? 8 plus 24. Now, generally, this is much more straightforward because you don't have to remember ukuthi masowuqedile kumele u-inverse. Here, it just gives you the answer exactly as it is. Then 8 plus 24. Then we get 6. So your RP. So nakhona, it depends on what you are comfortable with. But we are not done. Remember, the R that we have on that formula is not for RP, it's for the total. So how do we calculate the R external? The R external, we calculate it by saying R parallel plus R series. Note this. Every time we are dealing with a series parallel connection, to calculate the external resistance, we need to add the resistance of the parallel plus the resistance of the series, which means that RP here, we're going to have what? 6. And then which one is connected in series? The one in blue, right? The one without a different color there. Then 6 plus 3 is what? 9 ohms. So you see, it's worth the process of 7 marks now. So now, first thing that we had to get is R parallel. There we go. And then R external. There we go. Now, at this point, we are in a position to calculate that EMF. We are in a position to calculate that EMF. So if you can just allow me to erase here, I think everyone has now seen this. And then EMF, there is the formula. To calculate EMF, I need to say current R, we are not calculating the EMF, by the way, the current. We are given the RMF, the EMF. Then E is what? 12, EMF. Current, that's what we are looking for. R external, 9. R internal, 0.6. So you can see at this point that if in that 7 marks was a giveaway, Moss. So 9 plus 0.6 is 9.6. Then obviously you need to do what? Divide both sides by this 9.6. Then what's your current? 12 divided by 9.6. You get that the current is 1.25 amperes. 7 marks in the bag. .25 amperes. So a mark here, a mark for substitution and this, right? And then a mark for having to add the 2 and then get that. So already from doing this, you have 4 marks. So which is what I normally say, that even if you don't know the whole process up until the final answer, you can always do some of the things that you know, and then you'll end up with marks. Don't just give away that 7 marks and say, this question is difficult. A person who gets 3 out of 7 is way better than the one who leaves the question because they will just get 0. You know with physical sciences that if you can just identify the formula and substitute into the formula, that is something. Don't leave any marks there. Then when it gets to this part now, the remaining 3 marks is obviously for this formula, substitution, and the correct answer. Then that's the 7 marks there. So important thing to note this, and then adopt that color scheme method. So I will also share videos where I do this process, right? So make sure that you go over those videos and understand how this whole color scheme method works. Okay, then I believe we have noted, right? We have noted, right? Right, all right. Then determine the reading on the voltmeter. Now, this is a 3-mark question. At this point, everyone knows how we deal with 3-mark questions. Formula, substitution, correct answer with the correct SI unit. So we want the reading on the voltmeter. Which voltmeter are we talking about? This. So that means we are reading what? It's not 12 volts, right? Remember, the voltmeter at this point, when the current is flowing, when switch S is closed, the voltmeter is reading the V external. So that's what we are being asked to calculate, the V external. Now, the formula for the V external comes from this, R is equals to V over I. If we make V the subject of the formula, this becomes V external is equals to I multiplied by R, where your I is the total and the R is the what? The external resistance. So remember, we just calculated this. It's a follow-up question. So you should know that whatever that you calculated above will apply below. So it's 1.25 multiplied by the total resistance, which we calculated and got 9 from the 6 that we got from all of this and the 3. Then when you multiply those, so it's a straightforward question. Formula, substitution, and then multiplying those, grab your umshinwe ibalo, 11.25 volts. Don't forget the SI unit. 3 marks in the bag. Now they say, will the reading on voltmeter V increase, decrease, or remain the same? Will the reading on voltmeter V increase, decrease, or remain the same? If what happens, or here they're saying, the switch S is now open. Okay, switch S is now open. Now understand this, guys. If switch S is now open, that means current now, when it flows, it will flow like this. But then it will not flow to that part, mainly because remember, if this is not closed, that means current does not come over here, right? So it means current will just flow to this part only. Meaning now the 15 ohm and the 9 ohm resistor are being excluded from getting the current. Meaning now what we are seeing is that the 8 ohm and the 3 ohm will be connected in series. So once wavula la, i-current ayikwazi ukudlula. Remember, current can only pass if it sees a way out. So kufana nokuthi bathi la mawuhamba la bathi yo lapha ngidluleki lapha kunomgodi. So you wouldn't even dare to walk that part because obviously by the time you arrive here, you have to turn back again and then choose the path that will lead you back there, right? So current doesn't go where it will not be able to come out. So that means the 15 and the 9 ohm resistor are excluded, meaning you are only left with the 8 ohm and the 3 ohm resistor. They are asking now, how will this affect the voltmeter? How will this affect the voltmeter? Right, so this is how you are supposed to answer these questions. There will be the explanation here. At this point, I will leave this one and then focus on having to understand this and analyze what happens here. Remember, the only resistor that was connected in series was the 3 ohm. But as soon as we exclude those ones, it means the 8 ohm and the 3 ohm now are both connected in series. If we can just check, our R externally previously was 9 ohm. That was the old one. But now the R external would have to be what? 8 plus 3, which will give us 11 ohm. Now when you explain, you start by this. So I normally call it the ORC method. Tell us your observation. Your observation has to speak about the resistance. So point number 1. Now I'm on 9.5. I'm still going to come back to 9.4. I'm going to say the total resistance does what? The total resistance increases, right? The total resistance increases, which means because of the relationship here between resistance and current, which is inversely proportional, it means the current, the total current decreases. The total current decreases. Why? Because of this. R is inversely proportional to what? To current. So the greater the resistance, the lower the current, right? And then which means now what happens is that if the total current decreases, the V internal decreases and the V external increases to maintain a constant EMF and internal resistance. So I will explain now what that means. So basically what you need to take from this is this. So the relationship is if a current increases, then note this, V internal increases, and then V external decreases. But if current decreases, then what happens is always V internal decreases as well, and then in turn, V external increases. So these are the facts that you always need to know. Now, you will note that the EMF of the battery and the internal resistance always remains the same, because when you buy a battery, whether you connect more resistors or less resistors, if the battery is 12 volts, it's 12 volts. Nothing will change that. What will change is how much it supplies into the circuit. But it won't change the fact that it's 12 volts, meaning that if your battery now wants more than 12 volts, then your battery won't be able to take it. If your whole circuit needs more than 12 volts of energy, then your battery won't be enough to take it. You'd have to buy a bigger battery now. So the EMF will always remain constant. And also another thing, the internal resistance here will always remain constant. So if your battery is supposed to take 0.6 ohm of internal resistance, it will not change. It will always take 0.6. So what we know is that EMF and internal resistance always remains constant in all situations. So basically, this is all a battle to keep the EMF constant. So EMF, remember we said, is V external and V internal, which means if I'm going to be increasing the V internal, if I want to keep my EMF constant, then I have to make sure that the V external decreases. So in other words, the V external and the V internal will now be inversely proportional. So if V internal increases, then V external has to decrease. If V internal increases now, like this, then what happens is that V internal must decrease. So this is the relationship that then goes here. So because we had explained here, number one, the total resistance increases. But if the total resistance increases, the total current decreases. Now, which means the total current will lead us to this. What happens if total current decreases? We know that V internal will decrease, and in turn, V external increases. Why that happens? To maintain a constant EMF and internal resistance. That's how you always explain that. So if you can know these facts here when it comes to explanations. Now, the nice thing about this is that even in grade 12, those questions will not change. If you can master them from here now, then in grade 12, it's just a walk in the park. So which means, how do we answer this question? Remember, this was all an effort to answer 9.4. Voltmeter V represents what? The V external. What did we say about V external? It increases. So my answer here is what? Increase. Increase for 9.4. Then 9.5, there goes my explanation. The total resistance increases, the total current decreases. V internal decreases, and the V external increases to maintain a constant EMF and internal resistance. Awuyile nale. Ayijika shayisa. Noted, noted. Okay, please repeat the explanation for 9.5. All right, so we are saying here, what happened is they are telling us ukuthi switch S sekavulekile la. Switch S is open. So if switch S is open, that means current will not be going to this compartment here, this part. Why? Because current does not go where it will not have an idea of how it will come out. So if you open the switch here, it means that current will not be able to flow from this point all the way back to this point. Because obviously, let's say it flows. It will flow like this, it will flow, it will flow, it will flow, it will flow. But what happens here? Akusachambekile. So in other words, current will not be able to come here because current always wants a way to come out back to its initial point. So if it starts from this positive terminal, it needs to come back to this negative terminal. So because with this one, the switch here is open, it won't be able to come back here. So we are saying that current won't be able to flow to this part, meaning this part is being excluded from getting current. Meaning the only two resistors that will be getting current is what? The 8 ohm resistor and the 3 ohm resistor. But we can see that actually excluding these ones changes the 8 ohm resistor from being connected in parallel to being connected in series with the 3 ohm. Last time when we calculated the R external, it was 9 ohms. But this time when we calculate the R external with these two resistors, it will be 8 plus 3, which will give us 11 ohm, which our observation is that the external resistance is what? Increasing. Remember, ibuyela kuphi? Ibuyela kule part lesithe when you add resistors, right? When you add resistors in series, the total resistance will increase. Because we just added another resistors in series, the total resistance we saw it increased. Therefore, our first explanation based on the observation, we say the total resistance increases. That is point number one. This is an observation. From the previous to the new one, the total resistance increases. But according to a relationship, a formula, we know that resistance is inversely proportional to current. So if we are saying with a resistance here increase, then that means the current here decrease, which is what we spoke about. Go number 2. So when I was explaining that thing, it's ORC. First is observation. Number 2 is relationship. What is the relationship between that resistance and current? The total current decreases, right? Because of this relationship, are inversely proportional to current. Now, if the total current decreases, sibuyela la, these are the facts that we need to know. Every time current increases, EV internally increases, EV externally decrease. But every time current decreases, EV internally decreases, EV externally increase. Here we have a situation of current decreasing. So we're going to say V internal decreases and V external increases. But why does that happen? It happens so that we can maintain a what? A constant EMF and internal resistance. And there goes our explanation. But because U9.4 was asking us for whether the voltmeter is increasing or decreasing, now we answer and say it increases because uV la siyazi ukuthi akameasure EV internal, umeasure EV external, which is the one that is being supplied throughout the circuit. So we say V external increases. Therefore, our answer here became increases. And then for 9.5, that's the whole explanation now. Hope it makes sense. Then, okay, that's the 3 marks there. And then, kuzoba ne question, obviously, cost lapho, cost of electricity. A learner uses an electrical heater of resistance what? 48 ohms. 48 ohms. That operates at a potential difference of 240 volts to heat her room for half an hour. For what? Half an hour. This is the time. Half an hour. Calculate the cost of operating the heater if the cost of electricity is 2.56 per unit, right? Now, every time we calculate the cost, the formula is like this. Cost is equals to kWh multiplied by the tariff. Meaning, before we can do anything, why is it 5 marks though? It's because kW represents what? The power, right? The power in kilowatts. So we can see that we don't have the power yet, but then we have the formula that can allow us to calculate the power. So power can be calculated by saying voltage multiplied by the current, or power can be calculated by saying V squared over R, or power can be calculated by saying I squared multiplied by R. Obviously, you will take the formula based on the information that you have. And yet, you don't just pick and choose any formula that you feel like using, but then you'd have to be guided by data yakho. So your data is telling you that you have resistance and you have potential difference. So with resistance and potential difference, it means the only formula that you can use to calculate the power is V squared over R, formula number 2. Then you're going to say, what is my V? 240 square. Resistance is what? 48. Then, shagumshinwe ibalo-ke lapho. 240 square divided by what? 48. 1,200 200 watts. That's the problem now. When we want to calculate the cost, we don't measure in watts, we measure in kilowatts. Now, what is the conversion? From watts to kilowatts, you need to divide by 1,000, right? So note this when it comes to cost of electricity. That means I will say we still need to get my power as 1,200 divided by 1,000. So my power in kilowatts will be what? So ungayikhohlwa leyo. So 1.2 kilowatts, right? And then that's the one I'm going to put here, 1.2. So that's for kW. Now H, as you can see here, H is for hours. Our time here is not calculated in seconds. At this point, the time should be calculated in seconds. When we measure the cost of electricity, it must be in hours. Because if they were measuring in seconds, that means you'll be paying hella crazy for your electricity. So now they measure the rate in hours. But then this is half an hour. Half an hour. Half an hour. Half an hour is what? Half an hour is 30 minutes. And it is long or less. Not for 1.5 hours, for half an hour, which means 30 minutes. But now, obviously, we want your time in hours here. So we can't put 30 minutes here. We must put what? So we're going to say, if we want to convert minutes to what? To hours. What do we do? Divide by 60. Another conversion that you need to know. So that means we're going to say 30 divided by 60, which half an hour gives us what? 0.5 hours. That's half an hour now. So you're going to take that and then you say, okay, I have 1.2 multiplied by what? $0.5 multiplied by what? The tariff is what? 2.56. And then you simply grab your calculator now. 1.2 multiplied by 0.5 multiplied by 2.56. And then you get what? It's 1.536, which is 54 rands. So 1 rand 0.54. So that would be the cost of electricity there. So the cost of operating that electricity for that amount of time is that, right? So cost is equal to kWh multiplied by the what? By the tariff. Okay, we are done. And then question 8 now. Question 8 now. So we have what? Question 8, a circular coil with 250 windings or turns and a radius of 0.04 meters. Note that we are given what now? The radius, not the area. And then they say it's a what? A circular coil. So if it's a circular coil, that means it's in the shape of a circle. So our area is pi r squared. So to calculate the area, we need to say pi 0.04 and then square is equals to what? Pi multiplied by 0.04 and then square that. Okay, so we're just going to leave it as 0.04 square. What is it? So let's just leave it as 0.0016 pi. Yeah. Then that's our area. 8.1 says calculate the magnetic flux through the coil at the position indicated on the diagram while the coil is perpendicular to the field. Now, if that is in that position, we say that is the position of what? That is the position of 0 degrees, right? If it's perpendicular to the field, it's in the position of 0 degrees there. Then to calculate our magnetic flux, that's phi is equals to BA cos theta. Then our B is what? We are looking for something at a magnetic field. Remember, on that formula there, BA cos theta, our B is what? Is the magnetic field strength. And then our A is the what? Area. And then theta is obviously the angle, right? And then phi here is the magnetic what? Flux. Magnetic flux, which is given in what? Webers. This one is given in what? Teslas. Area is given in what? Meter square. Then B is what? B is the 3.2. Area is what? We have calculated the area already. Let's substitute it as 0.0016 pi, and then cos what? Cos 0 degrees. Because we know at 0 degrees, that's where it will be, that's where it's going to give us a magnetic flux, right? 90 degrees is not going to give us a magnetic flux. It's going to give us 0. 3.2 multiplied by 0.0016, and then shift pi cos 0 degrees. Remember, I did say that if they did not give you the angle, assume that it's going to be 0 degrees. Unless now they come and give you an angle, that's the angle that you can use now. So when you punch all of that into your calculator, when you punch that into your calculator, it's 0.016 Webers. Now, so it's your 4 marks like that. Then if the coil rotates clockwise through 25 degrees and the EMF induced is 2.8 volts, calculate the time in which the rotation took place, the time, right? So obviously, if they're mentioning about EMF, we know besides this formula, we have another formula, which is this one, right? So this is for 8.1. So this was for all for 8.1. We had to first find the area, then Cizella. Then for 8.2 now, what do we do? E is equals to negative N, change in phi over what? Delta T, right? And then our EMF is what? They're saying it's 2.8. How many number of windings do we have? 250 now. So this is negative 250. And then the change in phi will become what? Remember, with the change in phi, they're now saying this is from what? This is moving from 0 degrees to 25 degrees. Change in phi should be what? Should be like this. So let me say BA bracket cos theta finally minus cos theta initially. And then we close over what? Delta T, which is what we are trying to calculate. Now we're going to have 2.8 is equals to negative 250 like that. And then what is our B now? Our B was the magnetic field strength. 3.2, and then multiply by the area of 0.0016, and then pi. Okay, I don't think it's gonna fit all in here. So let me just do the question here. So E is equals to negative n change in phi over delta t. We have 2.8, right? And the number of windings was 250. This one we say we're gonna break it to BA bracket cos theta finally minus cos theta initially over what? Delta t. Then we have 2.8. If you want your work to be neat, you can actually calculate this alone by the side so that you don't have a string of numbers like I do. Then B here is supposed to be what? Is that 3.2. So 3.2 multiplied by 0.0016 pi, and then bracket, we have cos theta. Now they're saying this is moving to an angle of 25 degrees, but initially it was at an angle of 0 degrees. So make sure that you punch everything well in your calculator here. Now, obviously, what you need to do here if you're looking for delta t is now swap the positions between 2,8 and delta t. So we can put delta t there as the subject of the formula and bring the 2,8 here. So yeah, kuzomele ube careful again a calculator here, which is I would advise you to just calculate change in phi by the side, find the answer to that one and come back here. So negative 250, we have 3.2 multiplied by 0.0016 pi, and then bracket cos 25 minus cos 0, then close bracket, then 2,8. So all in all, we get what? To 2 decimal places, punch it into your calculator, we get 0,13 seconds. So you make sure you punch your calculator well. 0,13 seconds. So yeah, you must know how to apply that formula. So what I could have done is just calculate BA cos theta finally minus cos theta initially. By the side here, find the answer, then come back and substitute it here so that angibi nento engaka. Right, all right. Okay, then 8.3, which law can be used? Yes. It's always the same cases unless you are given an angle like this situation back near 25 degrees. Then it means you no longer apply the 0 and the 90. So you see, in this situation, they actually told you the coil rotates clockwise through 25 degrees, which means it's no longer parallel or perpendicular now. It's now at a certain angle. So it's rotating at 25 degrees. But in a case whereby they did not give you an angle, then we always know that the initial will be 0 and then the final will be 90 degrees. In a case whereby they did not state otherwise. Okay, which law can be used to explain the phenomenon described in question 8.2? Now, obviously, is Faraday's law. And then it's 3 marks because you need to then state it. So you mention it and then you state it. Faraday's law states what? States that the magnitude of the induced EMF, the magnitude of the induced EMF across the ends of the conductor is directly proportional to the rate of change in the magnetic flux linkage with the conductor. Yes. So the magnitude of the induced EMF across the ends of the conductor is directly proportional to the rate of change in the magnetic flux linkage with the conductor. So 1 mark for mentioning Faraday's law, 2 marks for defining Faraday's law. So yes, everyone at this point should know my definition. You don't want to find yourself losing marks just because of a lousy definition. Then 8.4.1, if the circular coil is replaced with the square coil now, with a side length of 0.04 meters, and the same movement is made in the same amount of time, will the induced EMF be the same as, larger than, or smaller than the circular coil? Write down only the same as, larger than, or smaller than. Now, obviously, here it will be based on you having to find the difference between ama area wako. So with the circular coil, it was pi r squared, which gave us what? Pi multiplied by 0.04 square, which when we do it, it gave us what? What was the area? So let's just quickly calculate it. And then we saw that the area is something like 0.005 meters square. We can just round it off to like 3 decimal places. Now let's see with a square is side multiplied by side. So 0.04 multiplied by 0.04, then it's going to be what? 0.0016 meters square. Right. Now, comparing the two here, we can see that this one here is bigger than that one. How do we see that it's big? After the comma 1, 2, 3, no 5, after the comma 1, 2, 3, no 1. So don't be confused by 5 and 16 here. You count in respect to the decimal places. So in the third decimal place, we have 5. In the third decimal place, we have 1, meaning this is bigger. This one is what? Smaller. So we can see that changing the circular coil into a square coil actually does what? Decreases the area. According to this formula, if our area now is smaller, it means the magnetic flux linkage will also be small. And if the magnetic flux linkage is small, then that means EMF is also small. Okay, sorry for that. So, yes, I was still explaining. If the area now will be smaller, as we can see now, comparing this and that, when it's a square coil, the area becomes smaller as compared to when it's a circular coil. So because the area is becoming small, it means the magnetic flux linkage also becomes small, and therefore the EMF will also become small. So our answer here is what? Smaller than. Smaller than. So it's a matter of just comparing with ama area wakazobanjan. So here when we explain, we say the area of the square, is smaller. We just explain our observation. Is smaller than the area of the what? Of the circular coil. So that's it. That's our explanation. So thus EMF will be small. Thus EMF will be small. So nothing deep. You just tell us a relationship up. Nothing that deep. You just tell us your observation in terms of the area being then it means that the EMF that will be induced will also be small. Because remember, another way of increasing the EMF is by using a water coil with a bigger area. So if we use a coil now with a smaller area, that means we are decreasing the EMF. Right. So that's it with that question. So it's easy here. This topic, it's easy to just score your 100% here. Very easy. Go through your notes, go through those few calculations, which we have already discussed. With the calculation, is will include a magnetic flask, the EMF. Those are the two formulas that you get to use there. Nothing beyond that. So it's a matter of whether they want the change in magnetic flask or they want the magnetic flask, which I've explained a couple of times. If they want the magnetic flask, the magnetic flask, then magnetic flask is BA cos theta. But if they want change in magnetic flask, it's BA bracket cos theta finally, cos theta initially, which mamba ngagnikanga my angle, assume this is 90, this is 0. But if they said ukuthi ama angle isuka from which angle to which angle, then you can put those angles there. Just like we saw with this one, 25 degrees here, 0 degrees, that one. Okay, then we move. Electrostatics. Question 7, Tiwani. So also here, low key, it's another topic that has a lot of marks. So you can see Lapo, the whole 23 marks. It's not a game. The whole 23 marks, if you can lose it, eh? And then I'm a definition out tula. Most of the time as well appear won't way 2, meaning with 4 marks in Jama. Electric field at a point and also Coulomb's law. As we can see here in this question paper, they appeared, both of them. Define the term electric field at a point. We say this is what? The electrostatic force experienced per unit positive charge. Per unit positive charge placed at that point. Right. So the electrostatic force experienced per unit positive charge placed at that point. It's as straightforward as that. 7.3, draw the electric field pattern between charges A and B. You see, so they say between. If they say between, then we know which one we draw. 2 identical metal spheres A and B on insulated stands are placed with their centers 10 centimeters apart. Sphere A has a charge of negative 15 nanocoulombs, and then while sphere B carries an unknown positive charge. P is a 0.2 centimeter away from the center of A, as shown in the diagram below. Draw the electric field pattern between charges A and B, right? So, sphere A has what? Negative 15 nanocoulombs. And then, while sphere B carries an unknown positive charge. We don't know, but then we know that it's positive. Now, if it's a negative and a positive, we know abo babigel baba attract attraction. So you're gonna say have ta, right? And then this is the negative, that one is the positive. So when they're attracting, should go something like this. And then do not want to over exceed ama electric field lines work, right? Make sure that you just draw a few. We are just only concerned about ukuthi kuzoyenzakalani lapho. So make sure only a few of them. And then so yes, something like this, yeah. And then on the positive, we know that they are inward there. Inward, and then positive, they are outward, like that. So positive energy, you spread it around. Negative energy, okay, even my fill lines here are not proper. So I must draw it like this. Direction of fill lines is also important. So it goes like this, yeah. Yeah. And then inward, 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 inward. So once you have shown okay, the charges are inward, going to the negative and outward going to the positive, then it's okay. Then you can indicate that this is your point A and this is your point B. So right. Injalo-ke, fill lines do not touch or cross. Correct shape, correct fill line direction, lines starting from sphere and not crossing each other. Those are the marking criteria. And then 7.3, wow, 8 marks. 8 la, 7 lap. You calculate the magnitude of the unknown charge on sphere B, right? The magnitude of the unknown charge. Now, what are we given here? We are actually given the net electric field. They say the net electric field at point P is 3.943 times 10 to the exponent of 5 nanocoulomb per, Newton per coulomb. So we know that with calculating the electric field, it's always the steering or a main point A or a main character lapho bani P. So this is A going to P and this is B going to bani to P. So we can do it as if it's for no calculator lapho and say, okay, if we were calculating EA, EP due to A, EP due to A, then how would we calculate it? We would say it's E is equals to EA is equals to KQA over R squared. Then that's 9 times 10 to the exponent of 9. QA2. Now it's time for us to check if there's any conversions that we need to do. Remember, nanocoulombs, you need to say times 10 to the exponent of -9, which I did say microcoulomb, it's times 10 to the exponent of bani, -6. Then when it comes to the distances, if you are given millimeters and you want to convert to meters, divide by 1,000. You see, I'm constantly reminding you those things. Ungathi yo say ngikhohliwe convert. Right. So note that. Very important when it comes to this topic. Then okay, then we're gonna say our QA is what? that 15, right? But then we don't substitute it as a negative. We put it as a positive there, and then over what? What is the distance between them? The distance is 2 centimeters. We need to divide by 100. 2 divided by 100, we get bani 0.02. Obviously, at this point, you want your calculator to be in scientific mode so that ama answers wakho azoyenza sense. But then even in normal form, you are still correct, right? So even in normal form, whatever that you prefer, guys, normal or scientific, still okay. Then we can now say, in normal form, I'm getting it as what? So punching it into my calculator, 337,500 Newton per coulomb, right? Which others are getting 3.375 times 10 to the exponent of, I don't know, 3 or 2, whatever it is. And then we have EP due to what? Due to B, which again, we're going to say EB is equals to KQ QB over what? R squared, which is going to be 9 times 10 to the exponent of 9. And then asiyazi le charge, this is QB. But we do know the distance. It's 8 centimeters, which is going to be what? 0.08, right? Then, what are we given there? They say they say the net electric field at point P is that. So if we want the EB, we can use the fact that we already have the E net. So E net will be what? EA plus EB. But again, we have to consider the directions. Where will P go due to A? P, remember, it's always a positive charge. So due to A, it will have to go to the left. Due to B, because B is a positive, it would have to be repelled again to Bani, to that point. So this one is always a positive point charge. So if we are saying this is positive, repulsion, P will go to the left. And then again, P will go to the left. So in this case, that means, let's just say we are taking our left as positive, since both of them are going to the left. And then we're going to say our E net is what? We've been given to be 3.943 times 10 to the exponent of 5. We have calculated our EA, 337,500, and then plus what? EB, which we can find EB by just simply subtracting this from that. Minus 337,500. Then it's 337,500 minus 3.943 times 10 to the exponent of 5 minus 337,500. Then which is giving us 56,800 Newton per coulomb, which I'm going to use it as my EB now. I'm going to use it as my EB. And then it's that 56,800 is equals to what? If I just divide these ones here, so 9 times 10 to the exponent of 9 divided by, here square, ne? I actually did put the square in my calculator. 0.08 and then square. And then we get to Ubani. .41 times 10 to the exponent of 12 QB. And then I can divide both sides by that. 1,41 times 10 to the exponent of 12, both sides. So this was a very interesting question. Then QB, 56,800 divided by that. Then you need that answer in scientific form. 4,04 times 10 to the exponent of -8 coulombs. Yeah. So yes, we had to use the fact that our E net has been already given there. So we used E net to find EB. After finding EA, then from that EB, we had to then use it here so that we find QB. So yeah, just needed to put your thinking caps on. Ziyabuya. Yes, phuzana amanzi, guys. Phuzana amanzi. It's gonna be a long one. It's gonna be a long one. Sphere B is removed. So yes, quickly note it down. Screenshot if you need to. Quickly, let's move. I believe we are done. Yeah, so siliqala la likhathaza khona le phepha. Then so that andifike la i-energy seyibhomile, at least if i-energy yeni iphela sesile phambili le, it's okay. Then sphere B is removed, state whether the sphere B is removed. State whether the electric field at point P due to charge on sphere A will increase, decrease, or remain the same. It will actually decrease because the presence of sphere B actually pushed it more to that side, pushed it more to the left. So if we are to remove sphere P, it will only just be attracted, but then nothing will actually push it there, right? It's like you are going to this particular girl here. If you are just alone, yes, you will go there, but then it's not the same as having the influence of friends saying, "Hambo mlanda, baba, hambo mlanda," right? So it will decrease your whole pride and ego, and the energy that you will be using there will be smaller. So we have to say decrease. Three, 100 microcoulomb, 100 microcoulomb conversion, and then the charges A, B, and C are equally spaced, 3 centimeter apart. The charges are a distance of 3 centimeter from each other shown in the diagram below, and each one of them is 100 microcoulomb. So state Coulomb's law in weights. Coulomb's law, we know, we are expecting it to be there. It states what? The electrostatic force experienced. Oh, I'm writing the other one. The electrostatic force between 2 point charges is directly proportional. To the product, or to the magnitude of the product, to the magnitude of the product of their charges, and inversely proportional. and inversely proportional to the square of the distance between them. So agna between their centers here. It's between them. Square of the distance between them. So that's Coulomb's law. The electrostatic force between 2-point charges is directly proportional to the magnitude of the product of their charges and inversely proportional to the square of the distance between them, or between them. Between them. Yes, between them. Yebo. So know it, know it. So you are having a rundown of all the definitions that you should be expecting there. So do not lose those marks. Do not lose those marks. Not especially if after I've went through everything there. And then draw the electric field. Okay. 7.5.2, calculate the net electrostatic force experienced by point charge C due to charge A and B. So now, they are now making seaway to steering. Note that calculate the net electrostatic force experienced by point charge C. That means now it's A going all the way to C. Now we know with most of the time we are used to Liaga B, Ibe is steering. But this time when we read here, it was different. So that means now we are calculating from point A to C, point B to C. It's possible for them to do that. So note it here. Then we're going to say F of what? Of A on C. Siyaqala, F is equals to K, QA, QC now, because we are calculating what? Electrostatic force. Then that's 9 multiplied by 10 to the exponent of 9. Now, our thing is in microcoulomb. So 100 times 10 to the exponent of negative 6. 100 times 10 to the exponent of negative 6. The distance from A to C, all the way from A to C, is 6 centimeters, which is 0.06 if we want to divide by 100. Right. Then when you punch that into your calculator, you get what? So that's going to give us 25,000 newtons this time, and yet to which direction? To the right. Because it will be repelled. This is positive and that one is positive, so it will be repelled to the right. And then remember we are basing it on C. FB on C is going to be F is equals to K QB QC over R squared. Again, same thing. 9 times 10 to the exponent of 9. 100. So lenje bebagnigile, ne? 100. So this 7 marks here, you get to see with it's nothing difficult, most. It's a giveaway. 0.03. So this teaches you to not look at marks and think with ayashaya lentole. Sometimes other marks are just a giveaway like that. Then this will give us what? 100,000 newtons. To which direction again? To the right, because it will be repelled as well. Now, obviously, that means our F net now will be what? It's just adding the 2. They're all going to the same direction. So F net will be what? F of A plus F of B. And then 25,000 plus 100,000. Uzidlela 7 marks wakho nje. Mahal. 125,000 newtons to the right. Yes. So nothing difficult there. As long as you know which formula to operate, and then you substitute everything correctly, you convert correctly. Ichayile. So yeah, guys. We are killing this. Yeah. Yeah. So this is what you'll be expecting, guys. Yeah. You might just as well spend 3 hours with me explaining these things here, because also uzobhekana ne 3 hours lapho nawe, and then i 3 hours caliber, and it's not something nice. So your time is way better invested here. This is a much better investment of your time. What is coming on Friday? What is coming on Friday? Yeah. Yeah. Kuzokhuzwa kukhuziwe. Then question 6. Two satellites orbiting the Earth are situated on opposite sides of the Earth. Satellite A has a mass of 4,600 kg and satellite B has a mass of 5,300 kg. Satellite A is at a height of 28,000 kilometers above the surface of the Earth. Again, here we are given our distance in kilometers. We know that from kilometers to meters, when we convert, we multiply by 1,000. This is the conversion that takes place here. So kilometers to meters, you multiply by 1,000. State Newton's law of universal gravitation in weight. So almost similar to Coulomb's law. Almost similar. So later, every particle in the universe attracts every other particle, with a gravitational force, that is directly proportional. That is directly proportional to the product of their masses, and inversely proportional to the square of the distance between them, to the square of the distance between them. So in short, every particle in the universe attracts every other particle with a gravitational force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. Yes. Between their centers. Yes, that's the difference there. Between their centers. Say Charmaine, and I wanted to make that emphasis. So in electrostatic force, we say between them. In a gravitational law accelerate, in a universal gravitation, we say between their centers. And yet, here it's between their centers. So yeah. So note the similarities and the differences between these two definitions, meant to say. So injalo. Now, if you can check how many definitions we've been writing so far, uyabona ukuthi like it's actually 3 marks. If you can just be able to memorize wonke ama-definition wakho, be able to do those simple questions as ama-3 marks, then you can walk out with something. It's so easy to pass physical sciences. Passing physical sciences has never been so this easy. Bamba ama-definition wakho, ubamba bo 3 mark question. That's a smooth 40%. Then mase uya ke so practice ezinye ezinzima ke, now we are talking level 4, level 5, 6, 7. But just passing nje sesikhulumela ngokupass, which is at least get a level 3, 4. It's easy to do that. Very easy. Calculate the magnitude of the gravitational force between the Earth and satellite A. So obviously we pull up the formula. F is equals to G m1 m2 over r squared. Now the G belang uzushisa ikhanda. Just go to your data sheet. You'll be given a data sheet yakho. And then when we are talking about the Earth, imass here Earth inikiwe lapho. Yiyo le ebhaliwe mass of the Earth is over 5.98 times 10 to the exponent of 24. You take it from the data sheet. And then you have what? 4,600 over what? The distance between them. You're not going to put that 28,000 kilometers there. Now, another thing that you should note here, if they say above the surface of the Earth, remember, this should be from the center of the satellite all the way to the center of the Earth. Remember, we said between their centers. This is very important. Between their centers. So when it distance abakunike yona leba to 28,000, it's actually this. This is the distance that they gave you by saying that. They gave you the distance all the way. This is the surface of the Earth. The surface of the Earth is the circumference. And yet, this is the surface of the Earth. For all the people that say the Earth is round, this is the surface of the Earth, right? And then we want to say we are given the 21,000 kilometers, but we want to calculate Tina from the what? From the radius of the Earth, which is the center of the Earth, and yet all the way from here. So if we are calculating from the center, that means we must also include the radius of the Earth. The radius of the Earth is also given. So always note if they mention above the surface of the Earth, then your R here down here should always be what? Your R should be represented by saying the distance that you are given plus the radius of the Earth. Please note that, because most of the time you find people just putting that 28,000 kilometers and then they forget about the radius of the Earth. So what you have here is from this part all the way to that part. But we calculate from center to center. So which means you will need to convert that 28,000 obviously, and then it becomes what? It's that if we write it in scientific form, it's going to be 28,000 multiplied by 10 to the exponent of 6 after multiplying it by 1,000. So kufana nokuthi it's 6 over nabo 0 by 6 now. So 28 times 10 to the exponent of 6 plus the radius of the Earth, which is given as what? 6.38 times 10 to the exponent of what? 6 meters. Then I'm going to add it to the distance that I'm given and then square that. So very, very important to note this. If the statement says what? Above the surface of the Earth. Now you have knowledge umuntu ongekho la angayas above the surface of the Earth. So you take the distance, you add it with the radius of the Earth because it's only representing from surface to la. But now we want from the center to la paya. I hope it makes sense. Then you're going to just punch your calculator to get all of that. Punch your calculator yako then it's going to give you your gravitational force is 1,552.29 newtons. So yes. So these two here are your constants. So mass of the Earth is 5,98 times 10 to the exponent of 24 kg. It will be given from the formula sheet. Radius of the Earth, it's 6,38 times 10 to the exponent of 6 meters. It will be given from the data sheet. So if you've been practicing my exam papers and you see something like this, you were wondering what why by add. Now you know. Konke laba ede corner, there is a statement that says above the surface of the Earth. Then 6.2 says calculate the magnitude of the gravitational force between the Earth. Oh, we calculated that. Explain the term weightlessness. No, weightless. Ngeke ngikhona. Weightlessness. Yes. So weightlessness is, there is the definition. Weightlessness is the sensation experienced when all contact forces are removed. So this is the clear, straightforward definition. The sensation experienced when all contact forces are removed. So ni na nayo leyo. So they might bring something like that. It's not. So you see here what they were doing. Almost topic amaningi had two definitions, which was this is a giveaway, yo. So Kshoguti, in this case, your definitions were more than 20 marks. You might find with your definitions were worth like something like 26, 28 marks. Just definitions alone. Which if you are there, if you get a question, I would 2, 3 nyana from multiple choice. Already that gives you, come on, guys. Passing. Let's go pass, guys. What distance above the Earth's surface should satellite be to experience the same air force towards the Earth as satellite A? Right. So answer only greater than, less than, or equal to, then explain the answer. So what distance should it be? They say, what distance above the Earth's surface should satellite B to experience the same? So what did they say about satellite B? It actually has a bigger mass, 5,300. Okay, then the distance that it should be should actually be what? Above, to experience the same force towards the Earth as satellite A. So satellite A has a mass of 4,600 kg and satellite B has a mass of 5,300 kg. Satellite A is at a height of 28,000 kilometers above the Earth. And then K. So if we look at this, F is equals to what? G M1 M2 over R squared. So we are saying the mass here is greater. So if the mass is greater, that means also the distance is the force, that the mass would have to be great. Let's check. Okay, let me find out by calculation. So I have F is equals to G M1 M2 over R squared. Then we should still experience the same force. They are asking to still experience the same force. The force was 1,552.29. So I want to answer this question based on a calculation because I don't seem to get it. 6.67 times 10 to the exponent of negative 11. Then mass 1 is what? Mass of the Earth is 5.98 times 10 to the exponent of 24. Now the mass of satellite B is what? 5,300. Then we want to know what should the distance be. So R squared here. Then if we cross multiply this, we already know we are just going to swap this. 6.67 times 10 to the exponent of negative 11, 5.98 times 10 to the exponent of 24, and then 5,300, and then over what? 1552.29. And then we can actually square both sides like that. Therefore, our R is going to give us what? 3.69 times 10 to the exponent of 7 meters, right? And then note that this is the whole distance that we have there. But then what was the distance that we had initially from adding the 28,000 multiplied by 10 to the exponent of 3 plus the 6.38 times 10 to the exponent of 6. I want to compare it with that distance. So if we say 28,000 times 10 to the exponent of 3 plus 6.38 times 10 to the exponent of 6, we get what? 3.438 times 10 to the exponent of 7 meters. So looking at this distance and that distance, we can see that this one is greater than. So yeah, it means now our answer is that it should be greater than, because we see that the distance that we have now when we put the 5,300 becomes greater than when we have 4,000, when we have satellite A, 4,600. So yes, because this one is a greater distance, our answer here is supposed to be greater than. Then also a calculation is an enough explanation. When they say explain, it doesn't necessarily mean you must only explain in words. If in this calculation proves as explanation, because now I will say 3.69 times 10 to the exponent of 7 meters is actually greater than what? 3.438 times 10 to the exponent of 7. So I have offered an explanation like that. So in a case whereby you can't put it in words, you can offer a calculation, and then your calculation will be a form of an explanation. Unless maybe a statement is it, now it's restricting you to explain in words, then there you don't have a choice. So yes, answer is greater than. So 4 marks like that. All right. I know. Now we are on to lighter things now. We have case number 4, Newton's law. Case number 4, Newton's law. Case number 4, we know it refers to objects being on an incline, right? So they say the diagram below shows a 3 kg block connected to a 1 kg block with a light inextensible string. A constant horizontal force of 20 Newton pulls the system along a rough horizontal surface. Now, I did mention this, that the force is only being applied on the 3 kg, and the 1 kg is only just being pulled up because it's connected to a block P by a string. But then the 20 Newton, note that it's being applied to the 3 kg. Now, always be mindful of our statement that come below there, that are always below the diagram, right? They do it deliberately so that you don't pay attention there. The frictional force between block P and Q and the surface is 2 Newton and 1 Newton respectively. Respectively means in that order, meaning P is 2 Newton Fk, and then Q is what? 1 Newton. You see. Then state Newton's second law of motion, we already know, and expect that definition to come. Then, itini, when a net force is applied, on an object of mass, the object will do what? The object accelerates in the direction of the net force. Then you start with the relationship. The acceleration is directly proportional to the net force and inversely proportional. So it's a very long definition, but you have to know it. And inversely proportional to the mass of the object. To the mass of the object. Injalo. So when a net force is applied on an object of mass, the object accelerates in the direction of the net force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object. That's how it goes. That's how it goes. Right. So know that definition. Meditate upon that definition. Sleep and dream of that definition. Draw a label-free body diagram showing all the forces acting on the 3 kg block. We celebrate when we see things like this because we know 3 marks, 5 marks, 5 forces. Dot. You have your normal force, which is always perpendicular to the surface in which an object is placed. You have your force applied there. So force applied, normal force. Remember I said do not resolve the components here. So fagu FG wako straight down. And then you have 3 now. What else? If the strings are attached, there is tension. Right? And then, since it's being pulled up the incline, Fk. So that's it. 5 marks, 5 forces. Make sure exactly as it is. And you can see my Fk. I hambe kanje. You all have the tendency of drawing Fk like this. Stop. Fk must be parallel to the surface. Right? Fk must be parallel to the surface. Fk does not oppose the force applied. Even if the force applied is the force is being applied at an angle. Most of the time you do that if you see with maybe force is being applied like this, and then someone comes and put Fk like that, maybe on a horizontal surface. The duty of Fk is not to oppose the force applied, is to oppose the motion of an object. And this object is moving up the incline. So if it has to be opposed, it has to be down the incline. So make sure your tension, your Fk parallel to the surface. And then your Fn perpendicular to the surface. So those are the things that you need to note. At this point, I'm not expecting anyone to lose marks on free body diagram. Calculate the magnitude of the acceleration of the 3 kg block. Now, at this point, we know that since we are dealing with the system, we also have to kind of draw the free body diagram for the 1 kg block because we will need to use it as well. Normal force, Fg, tension is on this side because intambo ngithi ngapha ku 1 kg, then Fk. Right. So Fk, normal force, gravitational force, tension. These are the only forces that are there. Force applied is not on the 1 kg. Force applied is only on the or on block P. Then okay, siyaqala ke manje. We've been running with this a couple of times now. At this point, we know that with the Fg being here, we know that there is a presence of what? Before you can start with your calculation, always acknowledge the part that you are on a what? On an incline. That means somewhere there is what? Fg parallel. The fact that you are not supposed to indicate it does not mean it's not there. Right. Then Fg parallel. Always, whenever you are dealing with case number 4, object on an incline, always remember Fg parallel corner and it's always sliding down the incline. So NB, Fg parallel is always sliding down the incline. Now, when you topic in Ayena we have seen with question 5, question 4, question 3 will all be newtons, including question 6, it was also newtons. So you can just focus on newtons and then you pass your exam. And then we're going to say for block P. So make sure that you indicate when you are calculating so that it's easier for you and the marker to follow through. Remember, what's your positive direction? The direction of motion. This is being pulled up the incline. So positive and then negative like this. Positive and then negative like that. So rule of thumb is that you should always put your negative law UFK icon. Right? Then it's going to be what? For block B, it's going to be force applied, F net. Let's start with this. F net is equals to MA. So it's going to be force applied minus the Fg parallel minus the Fk minus the what? The tension is equals to MA. Then force applied is what? 20. This one breaks down to what? Mg sine theta singakhohlwa. And then we have Fk minus T is equals to MA. Okay, let's substitute everything now. Our mass, make sure with mass yakho nakhona it's in kgs. If your mass is in grams, divide by 1,000. Then we have 3 kg for this one. 9.8 sine, what's the angle there? 30 degrees. Fk for this one, they said it's what? 2 newtons. Minus T is equals to MA. Mass is 3 and then 3A. We know that your unknowns will be with tension or acceleration. The way siyenzeka kaningi ngakhona le question le, umuntu osayithola wrong ungiphula umoya. Then it's going to give me 3.3 minus T is equals to 3A. Then 3.3 minus 3A is equals to T. This is equation what? 1. And then for block A or P here, or block Q, for block Q, F net is equals to MA. Then what do we have for that one? Tension minus Fg parallel minus Fk is equals to MA. Tension we don't have. This one breaks down to Mj sine theta minus Fk is equals to MA. T minus 1 multiplied by 9.8 sine 30 degrees minus what? They said, what's the thing for that one? 1 Newton is equals to 1 multiplied by A. Then punch that into your calculator. Remember to punch it first with the negative there. Negative 1 times 9.8 sine 30. You don't include that negative uzokhala, because it's going to give you wrong answers. Negative 5,9 is equals to what? A. Then tension is equals to A plus 5,9. And this is equation 2. At this point, you just need to equate the two equations. Then you solve. So equate equation 1 and equation 2. So 3.3 minus 3A is equals to A plus 5.9. And then 3 so what can we say now? Negative 3A minus A is equals to 5,9 minus 3,3. Why does it seem like I'm going to get my acceleration as a negative? Was everything calculated correctly? 20 minus 3 times 9,8 sine 30 minus 2. And then this here, so 3,3 minus this, and then it's not going to be. What's 5,9 minus 3,3?
So when you transpose
Where?
3.3 or negative, negative, well, never mind.
I transposed well, I think. Where did I miss it? Somewhere. Oh, let's see. What's the mass here? 3 kg. Okay.
So when you think you said, can I please help you, Nessa? You were saying isn't it? It's 3,3 minus 3A is equal to A plus 5,9. So you transpose the 3 and then you transpose the thing. Oh, never mind.
It is correct. Apparently, what I'm seeing here with the memo, their mass was 2 kg and Bonabasipo 3 kg. Their mass was the mass that they calculated with on the memo is 2 kg. But here from the question paper, we have 3 kg. So if we calculated with 2 kg as they did, we could have found a positive acceleration. So yeah, there has to be an errata for that memo. So the reason it's negative, it's because they gave us the wrong mass here. So it was supposed to be 2 kg instead of 3 kg. That's why. So if we can change all of this and now calculate with the 2 kg. So this is what happens according to what they gave us. So we put 2 here, we change everything to 2. So this is 2A, and then this is 2A. Yeah. Then let's calculate again this part. It's going to be 20 minus 2 multiplied by 9,8 sine 30, and then minus 2, because everything is correct here. So it's 8,2. Yeah, that's what they got. 8,2, and then here it's supposed to be 8,2 minus 2A. Then let's change everything. 8,2 minus 2a. And then, yeah, now it makes sense. Then we can say, in this case, we will say negative what? With this one that we have, we will say negative 2a, bring over the a here. This is going to be 5,9 minus 8,2. So this is negative 3a. 5,9 minus 8,2. It's negative 2, what? 3. Then when we divide both sides by this negative 3, we get what? Acceleration is now what? Negative, positive 0,77 meters per second square. Yeah. So it's the mass. It's the mass that was wrong. It's the mass that they gave us. It's the mass that they gave us. So everything was correct. Meaning, if you find something like that in an exam, you should just calculate it as a negative. Hauna choice. Because that's what you have, Vel. But then, yeah, it's their mistake. It's their mistake. Meaning, they had to award people marks. If they do a mistake like that in an exam, then that means you only get 6 marks a year. If they do something like that in an exam, like a mistake like that, it means won't allow my marks for free. So it was their error on their side. So just note that with this question there, just change the 3 kg to 2 kg. Okay. Okay, right. Then done with that question. Done with that question. Yeah. Okay, yeah. So this is the question that we discussed on Saturday. So, okay, we'll just go through it again for in case maybe Konalana Nele I missed that one. A hovering rescue helicopter is a container of supplies with a weight of 1,960 Newton, hanging from a cable. The tension in the cable is 2,100 Newton. The effect of air friction cannot be ignored. Then 4.1 says, state Newton's first law of motion in weights. Then what do you do there? What is Newton's first law? So we had defined it. And then we said Newton's first law states that a body will remain in its state of rest or motion at constant velocity unless a non-zero resultant force acts on it. A non-zero resultant force acts on it. And then done with the definitions. 2 marks. Right. Then Batini, why does the container remain stationary despite the tension being greater than the weight? Then we did explain that it's because of the air friction being part of this. So yes, this is the gravitational force, and then the tension is greater there. But then why does it? We can see that the tension force here is what? 2,100 Newton, which according to this, we were expecting this would be moving up. But then what is actually balancing the tension here is the air friction that's in the same direction of the weight. So the F friction balances out the what? The tension. So we're going to say there is F friction for 4.2. So for 4.2, there is F friction. There is F friction on the container acting downwards. Which balances out the tension. Which balances out the tension. Yes, which balances out the tension force. Right. Or you can say there's an extra downward force. Then 4.2, calculate the mass of the container. Now, to calculate the mass, we can see we are given the weight of the container there. So, with the weight of the container being given, it's a 3-mark question. We know that weight is the gravitational force. Fg is equals to mass times gravitational acceleration. So it's 1,960 mass, and then we have 9.8 here as our gravitational acceleration. Dividing both sides by 9.8, we want to have our mass as what? 1,960 divided by 9.8 is 200. So we have 200 kg. So formula, substitution correct answer. Calculate the magnitude of the tension in the cable as the container is being pulled upwards. As it's being pulled upwards. There's a statement that we have here. There's a statement that we have here which says, now the winch inside the helicopter starts to pull the container upwards, meaning now the tension force is changing. Remember, if you now start to pull, that means you are exerting a tension force. So the same tension force because now we are starting to apply that tension force. Then 4.3 says 4.4 says calculate the magnitude of the tension. Hence, we are being told to calculate. We wouldn't be calculating if Beifan lab. They wouldn't say calculate and then 4 marks if still a base of fun. So calculate the magnitude of the tension at the cable as the container is being pulled upwards. Remember, the tension is 2,100 Newton at a point where the acceleration is 0 meters per second square. Because at that point we say F net is 0 Newton. This is stationary. So stationary. We know that when it's stationary, acceleration is 0 meters per second square, F net is 0 Newton. But at this point, there is acceleration. We are being told the acceleration is 0.13 meters per second square, meaning that F net is no longer equal to 0, meaning the forces are no longer balancing each other out. Okay, so what do we do in this case? Calculate the magnitude of the tension in the cable as the container is being pulled upward. You will notice that this frictional force must remain constant, must remain the same. So the fact that now we are pulling, it doesn't mean that the frictional force will change or the air friction will change, because this is still at the same position as they are saying, while the helicopter remains in its position. And if it's in the same position, that means it's still blowing with the winch at the same rate, or what you call that hoover there is still blowing at the same rate. If the hoover is blowing at the same rate, so hoover blowing at same rate means that friction is constant. Means that friction is constant. This is stationary. The helicopter is not moving. It's remaining stationary in its position. The only thing moving is the container, and it's moving upward. So what do? We explore these two situations. We say, let's look at the situation whereby the helicopter was still stationary. Helicopter stationary. We say, okay, the time the helicopter was stationary, F net equal to MA would be what? Would be that tension minus Fg parallel minus the what? The air friction, Fa is equals to what? 0, because here the acceleration would be 0, therefore F net would be equated to 0. The tension was 2,100, right? Or not FG parallel, just FG. Just FG, sorry for that. Then the FG was what? 1,960 minus force of air is equals to 0. Now let's calculate the force of air. 2,100 minus 1,960, we get 140. Minus the force of air is equals to 0. Meaning if we equate, the force of air would have to be 140 Newton. But remember, we are saying helicopter is still at that same position, right? Helicopter still at the same position. So in fact here I should say it's not the helicopter actually, it's the what you call the container stationary. Container stationary, because this is based on the container, not the helicopter. So the container stationary. Now the container accelerating. So we are now looking at the container accelerating. Remember, in both these situations, helicopter is remaining in its position. Remaining in its position. Doesn't move. So if the helicopter remains in its position, the hover blows at the same rate. Meaning even here in this situation, the force of air would still be the same. But what changes is the acceleration and the tension. So it will still be T minus Fg minus the force of air and then mass multiplied by the acceleration. Now the tension is no longer the same. So T. Fg, obviously nothing will change the gravitational force, because gravitational force depends on the mass and the gravitational acceleration. So the mass of the container did not change. And certainly the gravitational acceleration will not change because it's a constant. Then 1,960 here. The force of air is the same as the one we calculated previously for when the container was still stationary. 140, because the force of air depends on the helicopter. If we are saying the helicopter is not moving, it's still stationary at the same position, that means the air that is being blown by the helicopter will still blow at the same rate. So I need you to understand that. And then mass of the container is that 200. Acceleration is that 0.13 that they gave us now. Then here, negative 1,960 minus 140 gives us the negative 2,100. Then when we calculate here, that's 200 multiplied by 0.13, which is 26. And then to calculate our tension, it means it's 26 plus 2,100. Then our new tension now that the container is moving is 21,126 newtons. So obviously we are expecting that with a bigger acceleration now, if the tension will be bigger. So we had to explore it from two situations. First situation, we use it to calculate the air friction. Then we use that same air friction to continue and calculate the tension when the container is now accelerating. So we get 2,126 newtons. So that's how we were supposed to go about with that question there. So any question relating to that? Oh, we are fine. In the absence of questions, I will continue. I will proceed. Then, okay, now in 4.5, they're saying after an acceleration of a few meters, the container is pulled at a constant velocity of 0.8 meters per second. What will the magnitude of the tension in the cable be while the container moves upward at a constant velocity? So at a constant velocity, that's where they blew it. constant velocity. Constant velocity is taking us back to the acceleration of 0 meters per second square. What was the tension when this was at an acceleration of 0 meters per second square? It goes back to that tension that we calculated up there. Remember, when the question says write down or what will be, and then for 1 mark, it's usually something that you can just observe from the statement given. So our tension will go back to 2100 Newton, because this is the tension that we get when our system is at equilibrium. When the system is at equilibrium, when it is when the acceleration is 0 meters per second square. So the acceleration, the velocity being constant, and also the container being stationary, it's more like the same thing. Remember, if in Newton's first law says it will remain in its state of rest or uniform motion. So state of rest and uniform motion, they have the same result, which the result is what? Acceleration will be 0 and the net force will be 0. So 2100 Newton. That's it for 4.5. Right, then question 3. So yeah, we are wrapping up now. We are wrapping up. Question 3. A lighting extensible string connects two blocks A and B of mass 2 kg and 1.5 kg respectively. A 8.26 Newton force is applied at an angle of 20 degrees on block A to keep the blocks moving at a constant velocity. Again, they wrote it in bold. Constant velocity, we already know. Acceleration is 0 meters per second square. Across a rough surface to the right as shown in the diagram below. This is case what? In block A, we can see this is case 2, right? Case 2. Object is being pulled at an angle. The coefficient of kinetic friction between block A and the rough surface is 0.33. That's mu k, 0.33. Define resultant force in weights. What is resultant force? We say resultant force is a single force having the same effect as the sum of the forces acting together. So that's your definition according to your CAPS document. A single force having the same effect as the sum of the forces acting together. So even if you write a vector sum of 2 or more vectors, it's also going to be acceptable. A vector sum of 2 or more vectors. Or you just write a single vector having the same effect as the sum of all the vectors acting together. That one would also be acceptable. A vector sum of 2 or more vectors. So either one of those. 3.2. Calculate the magnitude of the frictional force acting between block A and the rough surface. Now, obviously, we know cases of normal force is case number 2. So we need to first calculate the normal force by saying what? Fg minus Fy if it's being pulled at an angle. So this is mg minus F sine theta. We have went through the cases and then make sure you check them up. So 2 multiplied by 9.8 minus 8.26 sine what? 20 degrees. Then you just punch all of that into your calculator now. 2 multiplied by 9.8 minus 8.26 sine 20. You get what? 16.77 49. So I'm avoiding rounding off before the final answer. So I'm rounding off to at least 4 decimal places. And then now what do we do? Take that and multiply it to the mu k. So 0.33 and then 16.7749. And then when you multiply that, you get what? 5.54 rounded off to 2 decimal places. Yes. So that's it, 4 marks. So apply the correct normal force case, and then after you have calculated the normal force multiplied with the coefficient, then you have your kinetic frictional force. Easy peasy, lemon squeezy. Yeah. Then 3.2.2. Coefficient of kinetic friction between block A and the rough surface. Block B and the rough surface. Block B. They want the coefficient now. So note that, let's just write, we already have Fk here, 5.54 Newton. Now we know what actually brings these two together is the tension here. So what we can actually do here is say, since we know that this is a system of blocks, and whenever we are dealing with the system of blocks, we know that the acceleration and the tension is the same. We can just say, let's deal with block A now. So obviously, even if there is no question that says draw the free body diagram, you know very well it's going to assist you in calculations. So you might as well try to draw it there. And then this is my tension and also Fk. Right. So obviously, because this one is a diagonal force, umalume lo, asimsebenzisa umalume sifuna abashana. So you have to resolve it to what? To Fx, so that you can apply it as a horizontal force. So it resolved to Fx and Fy. But then remember, when we are calculating Fnet, we are more focused on the horizontal forces here. So because this is being pulled to the right, this is the positive direction, this is the negative direction. So we're going to indicate for 2 kg block. And then this is going to be what? Fnet is equals to MA, which will be Fx minus tension minus Fk. So we want to be using this to calculate the tension. So let me say Fx minus Fk minus tension, since I'm calculating that, and then mass times acceleration. Then Fx breaks down to F cos theta. Fk, we have already calculated Fk for block A. So it's that 5.54 that we calculated, minus the tension, and then mass is 2, acceleration is 0 because of constant velocity. And then my force here is 8.26 cos what? 20 degrees minus 5.54 minus tension is equals to what? 0. Now, you need your calculator. 8.26 cos 20 minus 5.54, which is going to give us what? 2.22 minus T is equals to 0. So therefore your T is 2.22 newtons. So this tension here will not only be applicable to the 2 kg block, but also to the what? To the 1.5 kg block, because remember, a system of blocks will have the same acceleration and the same tension. So now, coming to block B, I will say for the 1.5 kg block, or block B, Fnet again is equals to MA. And then, free body diagram, there would be the tension, the Fk, the normal force, and the Fg, which brings us to case number 1. And then this is tension minus Fk is equals to Ma. So tension, now I can use the 2.22 minus Fk. Mass is 1.5, but acceleration is still 0 because this is a system, same acceleration, same tension. Fk now becomes what? That 2.22 newtons. So because here we can see that this will balance each other out since we have constant velocity. Then what happens here is that to calculate the coefficient, we need to break this one down further, mu k times n. So this is 2.22. But case number 1 teaches us that normal force is equals to what? Gravitational force. So this is m times g. And then to continue with that, we're going to say 2.22. Mu k, that's what we are looking for. The mass is 1.5. The g is 9.8. Divide both sides by that. 1.5 times 9.8. 1.5 times 9.8. Then mu k is what? So it's 2.22 divided by 1.5 multiplied by 9.8. Then it gives us our coefficient as what? 0.15. There we go. 0.15. So yes, that was the struggle there. That's 6 marks. That's how we were supposed to actually go about it. Right. So first we had to calculate the tension using the 2 kg block. Take that tension since it will be the same tension on the 1.5 kg. Use it there on the 1.5 to calculate the kinetic frictional force. From finding the kinetic frictional force, we break down the formula further to find the what? The coefficient, using the fact that 1.5 kg is case number 1 of the normal force cases, whereby the normal force is exactly equal to the gravitational force. Even with the free body diagram, we can see. So what do you learn from this? Even if they don't ask you to draw a free body diagram, as long as it pertains to calculations, it is better to draw the free body diagram. It actually works in your favor to draw the free body diagram. So yes, that's what we have there. That's what we have there. And then, yeah. So also I'm teaching you to conserve your energy as you are writing that exam paper. So you see, I was able to almost finish this exam within that 3 hours, even though I am still explaining. So your job will only just be to write. I'm writing and explaining, and I was able to finish it in 3 hours. So it should tell you something. A light string is suspended from the ceiling X. An object of mass 8 kg is tied to the string at O. A horizontal force of 60 Newton is exerted at point O, causing the string OX to experience a tension T as shown in the diagram below. The system is in equilibrium. Right, system is in equilibrium. Explain what do we mean by forces in equilibrium in words. So forces in equilibrium. So this one, most of us have done it. And then, yeah. So that means at this point, if you feel like you have everything that you need, then you may be excused. But then I'm still going to do multiple choice. Forces are in equilibrium when the net force acting at the point is equal to 0. So yes, is equal to 0. Draw a closed vector diagram showing all the forces acting at point O. Indicate the angle theta in the diagram. So we already know with this one, I said, take the forces exactly as they are. It's a cut and paste. Your gravitational force going down, followed by the force applied, and then your tension force closing off there. It doesn't matter the order in which you take the forces as long as you form that right angle triangle. You can start with this and then you go down and then you close off like that. It doesn't matter what shape you form. What shape you form, as long as it's a right angle triangle. Then this is gravitational force. This is your applied force, which is 60 newtons. And this is tension. And then your theta here if you are to take this, it's supposed to be where? So obviously, if you are applying the fact that you'd have to take it up like that, then you can see that it should be somewhere there. So as you can see, close off like this, close off like this, then your theta should be indicated there. Then, okay, now they're saying magnitude of the tension T in the string OX. How do we calculate the magnitude of the tension? So we have the 60 Newton. We can calculate the graph by saying Fg is equals to m times g, which is 8 multiplied by 9.8, which is going to give us what? 8 multiplied by 9, 78.4 newtons. Then you can put it here, 78 newtons. To calculate your tension, this is a right angle triangle. Your maths still applies here. You know that if you are given a right angle triangle, you can find the hypotenuse by using the what? The Pythagorean theorem. So T squared is equals to Fg squared plus Fa squared. Then which is going to be what? So we can just immediately put it inside the square root. Then Fg, that's 78.4 square plus the 60 square. You punch all of that into your calculator. It's going to give you what? 78.4 square plus 60 square. So which is going to give us 98.72 newtons. So that's the magnitude of the tension. So 3 marks, formula substitution, the correct answer with the correct SI unit. Then they want the angle now, angle theta that the string OX makes with the vertical. The angle, to calculate the angle, we can use, since we have all of this, we can use any trig ratio now. Use any trig ratio. But then the safest to use would be a tan, because we wouldn't be sure if what we calculated here is correct, right? So if you use tan, you'd only be able to use Fg and force applied, which is F force applied is already given. This one, obviously, you can just calculate that one by saying 8 times 9.8. You wouldn't make much of mistakes here. But then this is also to show you that even if you had failed to calculate the tension, you could still calculate the angle. So in this case, we will use tan. So assuming that, let's say we fail to calculate the tension, we'd still be able to get this marks. Tan is what? According to where theta is, the opposite side is this one, and the adjacent is this. So opposite to the angle and adjacent to the angle. So this is 60 over 78.4. And then theta now is arctan 60 over 78.4. And then punch that into your calculator. Arctan 60, 78.4. This gives us 37.43 degrees, rounded off to 2 decimal places. Right. Then 2.4 says, without doing a calculation, write down the magnitude of the resultant force at point O. Remember, we said these are forces in equilibrium, and we know with forces in equilibrium, the resultant force always is equal to 0. So 0 Newton, or you just write 0, doesn't matter, then that's it. So they actually gave you 2 marks there. So for just knowing that it's supposed to be 0, they gave you 2 marks. Nothing was supposed to be done there. It's not a matter of an SI unit or anything. You just had to write 0. So it shows understanding. It shows that you understand that, oh, what is actually... Okay, so we are saying because the forces are in equilibrium. Yes, because the forces are in equilibrium, the resultant force is 0 Newton. The resultant is 0 Newton if forces are in equilibrium. Even the definition says so. So what was the definition when we defined? Again, let's go back to the definition. Forces are in equilibrium when the net force, so the net force is the resultant force. When the net force acting at a point, acting at the point, which point? That point O, is equal to 0. So we got it from the definition. We got that from the definition. Forces are in equilibrium when the net force acting at the point is equal to 0. So this is what we were being asked here in 2.4. Without a calculation, write down. Remember, when it says write down, it's usually something that we saw from the statement. So the resultant force when forces are in equilibrium will always be 0 newtons. In fact, when you are able to draw a closed vector diagram, it simply means that your forces are in equilibrium. You cannot be able to draw a closed vector diagram unless your forces are in equilibrium. So the presence of the 90-degree there, you being able to draw a right angle triangle from these forces, indicates that the forces are in equilibrium. Hope it makes sense. So yeah, then so as I had advised, there are two ways in which you can attempt multiple choice questions. It's either you reserve them to be the very last question that you answer, or strategy number 2. If you are answering Newton's second law questions, then you can answer questions on what? On Newton's, multiple choice on Newton's only. You move to another topic. Let's say you are now dealing with your universal gravitation. You go back to your multiple choice. You only answer multiple choice questions on universal gravitation. You move to another topic. Let's say you are now doing Coulomb's law. Go back to your multiple choice. Answer questions on what? On Coulomb's. So in that way, you are able to finish off your multiple choice question without really investing the time in actually saying, I'm now answering multiple choice questions, because these ones, they can actually take you a lot of time if you actually start by solving them. So it's a very bad approach to start your question paper, your physics question paper, by answering question 1 multiple choice questions. Whether it's paper 1 or paper 2, that's a very bad strategy. So you want to tackle these ones with that strategy whereby you just answer a few, or you just answer all the questions and then you go back to it as the last question. What's the benefit of doing that? It's because these are conceptual questions. Whatever that we applied in solving is what is being asked here, right? So now that you have went through all those topics, it's easier to answer those multiple choice questions, because now you have went through all those topics and you have actually applied the concepts. But now if you're going to be starting with that, it means you have to think about 6 topics, 7 topics all at once, which for the first hour when you are still writing your exam, your brain has not heated that much to the point that you remember everything that you have studied. So you want to tackle this as the last question, or rather you break it down as I said. Now let's start 1.1. Which of the following is a scalar quantity? Now we know what is a scalar quantity. This is a quantity that only represents what? Magnitude. So a physical quantity, a physical quantity that has only magnitude, no direction. So force has magnitude and direction, velocity, magnitude and direction, acceleration, magnitude and direction. Almost all of these 3, when you calculate them, you also indicate the direction. But with speed, that's a scalar quantity. So D. Then that's your 1.1. 1.2, the object below are all identical and resting on frictionless surfaces. Which object will experience the greatest acceleration? Which one will experience the greatest acceleration? Now, obviously, you are looking for where when you subtract the two, you will find a what? A bigger net force. Remember, according to Newton's second law, so you see this is conceptual. We know that F net is directly proportional to acceleration, or acceleration is directly proportional to F net. That's your definition for Newton's second law. So the greater the net force, the greater the acceleration. But how do we calculate net force here? By simply subtracting the vectors. If we say 13 minus 10, that's 3 newtons. 12 minus 12, that's 0 newtons. No acceleration on this one. 7 minus 2, that's 5 newton. 24 minus 20, that's 4 newtons. This one produces a bigger net force, therefore a bigger acceleration. Answer is what? C. So how am I able to answer that? Because I've applied some of the concepts here now. Then 1.2 is C. Because of what? A bigger net force. And then 1.3, the diagram below shows two trolleys held together by a compressed spring. The trolleys are initially at rest on a frictionless horizontal surface. Trolley A has a mass of 2 kg and trolley B has a mass of 1 kg. The spring breaks and the trolleys move apart. The magnitude of the force that the spring exerts on trolley A is F. What is the magnitude of the force that the spring exerts on trolley B? Right? So obviously here, this goes back where? This goes back to Newton's third law. When object A exerts a force on object B will simultaneously exert a force of the same magnitude. That's the point. So if they're saying trolley A, if they're saying the magnitude of the force that the spring exerts on trolley A is F, what is the magnitude of the force that the spring exerts on trolley B? Now, obviously, it has to be what? F, based on Newton's third law. Then we are done. So your option there is B. Then we move. So all of these are conceptual questions. Then 1.4, a block slides to the left on a rough horizontal surface as shown in the diagram below. What are the directions of the resultant force and the acceleration of the block? Direction is there. A block slides to the left on a rough horizontal surface as shown in the diagram below. What are the directions of the what? Resultant force and the acceleration of the block. Direction of motion is that. According to Newton's third law, the object will accelerate in the direction of the net force. So that means here we are looking for the direction of the resultant force to be the same as the direction of the acceleration. That's it. So what is our option here? As we can see, direction of motion is to the left. Also acceleration to the left. Based on what? Newton's second law, the definition. When a net force acts on an object of mass, the object will accelerate in the direction of the what? Of the net force. Conceptual. 1.5. A crate is being pushed across a rough horizontal floor at a constant velocity. Note. If the force applied is suddenly removed, the crate will do what? Will it stop immediately? Or immediately start slowing down to a stop? Continue at constant velocity for a short time and then slow down to a stop. And then continue at constant velocity. According to Newton's first law and inertia, we know that if we suddenly remove that force, the object will still continue in its state of constant velocity, in its state of uniform motion, unless an unbalanced force acts upon it. So inertia says it will continue in that constant velocity up until the time it realizes, oh, the force is no longer there. So now it slows down to a stop. So that means our option is what? C. it won't immediately stop. Even if you were to do an experiment about it, it won't immediately stop. It won't immediately start to slow down because it has to respect inertia now. Inertia is the reluctance or the resistance of an object to its change in what? In motion. So now we have C. Now note that with all of those, there was nothing crazy in terms of the calculations now. It's just applying concepts. A satellite experiences a gravitational force of magnitude F on the surface of the Earth. The radius of the Earth is R. The satellite now orbits the Earth at an unknown height above the surface of the Earth and experiences a gravitational force of magnitude 1/4, 1/4 of the force, right? The unknown height above the Earth's surface is what? Is it R2, R3, R, or 4R? Now, obviously, this is the point whereby you would need to at least calculate. So they say the radius of the Earth is R. A satellite experiences a gravitational force of F. So G, M1, M2, and then R squared. And then they say the radius of the Earth is R. The satellite now orbits the Earth at an unknown height above the surface of the Earth and experiences a gravitational force of magnitude 1/4 of that. Right. So now we want to know the relationship that causes this one to be a 1/4 now. Okay. So what we are going to say is at this point, everything was just like this. G M1, M2 over R squared. But now immediately we now experience 1/4, 1/4 like that. And then GM1, M2 over what? R squared. Then they are asking this unknown height above the Earth's surface is what? So we can actually get that by multiplying by 4 both sides. And then we find that this 4 here will be, so this is 4GM1. So nothing actually happens to the radius there because this 4 only affects the product of the magnitudes of the masses. So that means our A here is still supposed to be R. So what actually caused the change there? What actually caused the change there would be that the satellite now, okay, they say the satellite now orbits the Earth at an unknown height. Okay, so is there any effect in terms of this? So, yeah. I don't think so. I don't think so. So I think what happens is that the mass would be affected. So they say, and experiences a gravitational force of magnitude 1/4 F. Okay. Right, then let's go to 1.7. So I would still need to go back to that one. 1.7, two identical metal sphere X and Y on insulated stands have charges of 6 nanocoulomb and -2 nanocoulomb, respectively. Y is brought into contact with X and then placed at its original position, right? And then they say, what is the direction in which electrons are transferred in the final charge on the sphere? Now we know that this comes from the fact that electrons, if we want to know electron flow, electron will always move from a sphere with excess of electrons to sphere with deficiency of electrons. So note this, a sphere that has excess electrons is not the one with a bigger number. It's actually the one with a negative value. So this one has excess of electrons. This one has a shortage, deficiency. So it's not about which number is bigger, it's about which number is negative. So this one electrons will move from Y to X because this one is an excess of electron, this one is a deficiency of electrons. So Y to X is correct. So I'm going to tick everywhere where it says Y to X. Now the challenge is, what is the final charge? The final charge is what we know as the Q net, which you calculate by saying Q1 plus Q2 over 2, which is 6 nanocoulomb plus negative 2 nanocoulomb divided by 2. 6 minus 2, that's 4. 4 divided by 2, that's positive 2 nanocoulomb. So that means this one would be incorrect because it's negative, meaning this is the correct one. So our option here would have to be what? B. So obviously these ones are wrong because they are saying X to Y. So they do not move from the positive to the negative there. They do not move from the one that is a deficiency to excess. It's actually from the one with an excess to a deficient. So the direction of saying Y to X is correct. Now it's a matter of deciding with the final charge which one is correct. So we calculated here and actually found that using this formula. This formula is from grade 10. This is the one that you use to calculate Q net, or sometimes they would refer to it as Q new, right? So it's the same formula, Q net or Q new. So you use it to calculate the new charge after the spheres have been brought into contact and then separated. So 1.7, the option is B. So yeah, that one, understandable. Then 1.8, two ohmic conductors P and Q are connected in parallel to a battery connected in parallel. The resistance of conductor Q is much higher than that of conductor P. How does the potential difference across the conductor Q and the current in Q compare to that of conductor P? Now, let's go back to our relationships. We know that with a bigger resistance, there is a smaller current. So the bigger the resistance, the smaller the current. But then resistance and the voltage, they are directly proportional. The bigger the resistance, then the bigger the voltage. So, okay, let's see here. When it comes to this, we must also note that with the parallel connection, in parallel, we say voltage is the same throughout. Voltage is the same. So that means let's stop with this relationship. It applies to a series, right? Voltage is the same throughout. So the voltage in here would have to be equal to the voltage in here. So that means the right answer would lie between A and B. Now it's a matter of, will the current be less than or greater than? Now let's say, they say the resistance of conductor Q. So this one is a bigger resistance. Let's say 10 ohm for argument's sake. And this one, let's say maybe it's 5 ohms, small. Conductor Q has a much greater resistance than conductor P. How does the potential difference across conductor Q and the current in Q compare to that of conductor P? So we know that the potential difference will be equal to, but the current in conductor Q will be less than the current in conductor what? P. So this one will have more, because the smaller the resistance, the bigger the current. The bigger the resistance, the smaller the current. So how does Q compare to P? It will have a less than current, right? So that means the answer lies on A. So you see how I tackle those questions. So I start by marking the correct answer from column 1, and then I go and decide based on column B which one of the two answers that I've marked has to be the correct. Has to be the correct one, yes. Okay, so it's A. It's A. It's A. Then 1.9. So I'm sure you are getting the skill of answering those ones. In the diagram below, the magnet is pushed into the solenoid, right? What will the polarity of point A on the solenoid and the direction of the induced current in the solenoid be? Now remember, what we know is that if this is being pushed with a north pole, then it actually induces this one here. to be what? To be south pole. So it's the induction. So north pole induces this one to be south pole, and this is what actually makes the magnet to be attracted into this, right? And then now they're saying, what will happen to the what? To the current. Remember that current always moves from north to south. So if this is being induced to be south, that means what we have here is the induction of north. So we know that current would have to move from north to south now, right? So it will move all the way like this, all the way like that. And then which is what? Q to what? To P. So from this point, it's Q and then to that point. So that means the correct one would have to be what? So again, marking here, I would say this one has to induce what? This one has to induce south, right? Wait, no, doesn't. Wait. It actually induces north. Now I'm messing it up. It actually induces north. Yes, it influences it to be. So north here induces north, and then this becomes south. Almost okay, so that happens when I take it out. If I'm bringing it in, then the Newton the north pole here induces this one to be north pole, and then which is why there's a deflection here. And then this is south. Oh, okay, north south, that means current has to move from P to Q now. Okay, then that means let me select the ones that say north. North is A and then D. And then current, if this is north, this is south, that means current have to move from P to Q, not Q to P. So this one would be incorrect. This one would apply if we were to pull it out. Then if we are pushing it in, then it's P to Q. So A would have to be correct. So north induces north when we are pushing. So yeah, these questions, most of the time you don't get them. You only find them in multiple choices like that. Then 1.10 now. Okay, the last one. 3 identical resistors X, Y, and Z with equal resistance are connected as shown in the circuit diagram below. If the power in X is P, then the power in Y is what? So all of them are of equal resistance. Then the power in Y, this one is, so this is P, and then they all have equal resistance. So then the power in Y is what? Is it A? Half P, 1/4 of P, or 2P? Let's find out. So we know that if here the current, if this one is the same, let's say if the current here is 2 amperes, then the current here is 1 ampere, and the current here would be 1 ampere because it have to split here. So how we calculate the power is I squared times R. If we can say 2, and then let's just say the resistance is 1. So all of them have a resistance of 1. So 2 square multiplied by what? By 1. This would give us 4 watts. But then let's calculate the power on these ones. I squared multiplied by R. This would have to be what? And then 1 squared times 1 is 1. So if we now compare 1 watt to 4 watts, we can see that the answer is supposed to be this. So the ratio is 1W to 4W, which is 1/4. Yeah. So the answer is C. The answer is C. The answer is C. So we had to just create values there. We had to create values that we're going to keep constant so that we see the ratio between the power that is generated by this bulb here and then the power that is generated by that bulb or resistor there, which is Y. So now we saw that when we calculate this one, it gives us 4 watts, but this one gives us 1 watt, which the 4 watts is 4 times that one for Y. So that means Y is 1/4 of the power that is being produced by X. So you can see that multiple choice is not just a matter of guesswork. There is some calculations that you need to apply and remembering of concepts, right? Remembering of concepts. So yeah, which makes it a little bit tricky to answer. So you see just the time it takes for me to just think of those concepts, remind myself of some other concepts that I had already forgotten. So, which is why I'm saying it's a bad idea to even start by answering your multiple choice questions. It's better that you go through all the content questions, and then you can come back to this one. So you know, even if they take your paper, they say time up, you can just do some guesswork there. Maybe you land with answers. But then I'm not advising that you just circle any answer there. Try to like understand the concept and go through the concept, and then try to apply that. So yeah, I think we've came to the end of our session. I don't know if someone is still typing a question there. Ririza. Yeah. Yo, 3 hours and 30 minutes, guys. Yo, it's crazy. Yo, I'm so tired. But then yeah, thanks, guys. Thanks for staying up until that long. So I hope it was worth it. Thank you, Ririza there. Very much appreciated. I hope it actually helps. So as soon as I'm done, the lesson is recorded and then it's gonna be saved. I'm gonna upload it and share the link on the groups so that you can go over it if you didn't catch anything there or you need to revise, recap anything. So yeah, kunjalo guys. Thank you. Atli, Benson, Buyi, Katleo, Lula, Mambali, Miriam, Nobile, Ririza, Sikhanyiso, Spogasi, Oscar. Yeah, no, it's been a blast. It's been a blast. So, okay. Uh, See you on Saturday, guys. Nibhaleni kahle ke on Friday. See you on Saturday. Please come to school. Let's revise our paper too, making sure with value for the last time we kill that physical sciences. For the ones that are attending on Sunday, it's still a business day. I'm gonna be taking you for the whole day in Alapo. Even 9 km Saturday, be prepared. I think I'm going to be taking you first 2 periods, if not all 3 periods up until to lunch. So we'll see, because I want to just do all the revision for paper 2. So if it requires 2 periods or 3 periods, we will see. But then you are with me this coming Saturday and Sunday. So yeah, kunjalo ke guys, all the best. Sharp, sharp. Sharp. Sibonge.